Hi there, I hope you guys are doing great. I'm Animesh and welcome to my YouTube channel. In this video, we are going to see what is an outlier, how do we identify outliers graphically as well as by calculation, and why it is important to identify an outlier. So let's begin. So first of all, by definition, outlier in the data are the points that lie very far from the rest of the data point. Now that the outliers are only in the numerical data, and the most important point is that the percentage of the outlier should be very less. It should be, for example, 0.5%. Because if the percentage is high, then that means that is not an outlier, that is the part of the data. Now moving forward, let us now find how we can identify an outlier graphically. Suppose we are having a sales data of some ABC company. Now we have the number of units sold per month over the years. So for example, in January it was 20 into 100, that is 2000. Then in February it was 3400, like that. And so we have it for all the 12 months. Here graphically, by plotting a scatter plot, we can see that in the month of September the sales were exceptionally high. So we can see that this data point looks like an outlier by drawing an inside with the graphical representation. We also want to identify the outliers by some calculation so that we can do it programmatically and we can automate the processes. Now there are various ways across the industry with which we can identify the outlier. So I'll be taking up only one way of identification in this video, and in subsequent series I'll be taking up more ways of identification of outlier as well as how we can deal with those outliers. Okay, so let's understand one way of it moving forward. So one way is that we calculate the median in that numerical variable. Also we calculate the quartiles, that is specifically quartile third as well as the quartile first, and we take out the difference of it, quartile 3 minus quartile 1, which gives us the interquartile range. Okay, this interquartile range is multiplied into 1.5 and plus the median value. Whichever value is coming up out of this is our limit, beyond which if there is any value in the data, that is an outlier. So did you get my point? So here the box plot is a very good visualization with which you can understand what are the quartiles, what is the median. So if I plot a box plot of a numerical variable, the middle line you see over here, it shows us the median of that numerical variable, and these lines within the box, the extreme line shows the quartile 1 as well as the quartile 3, that is the upper quartile as well as the lower quartile, and the extreme whiskers, the minimum and the maximum, gives us the value of minimum and maximum of that numerical variable. Now you must be thinking, then if it's minimum and maximum, then the outliers should fall within this, but that is not the case, because this minimum and maximum is basically the 5th percentile of the data, and this is 95th percentile of the data. So if there is any value beyond 95% of the data, that is an outlier. So did you get my point? So if your basics are right, you will not have any problem building on any complex scenarios from there on. Now moving forward, how we can calculate using this information that we just get. So we have this data, and so I would like you to show it on the Jupyter notebook how we can programmatically calculate it, so that it will be a hands-on experience as well for us. Now we are on the Jupyter notebook. So I have imported some important libraries like pandas, numpy and seaborn just for our visualization. So let's begin with a small visualization that we just saw, the box plot. So I'll just plot the box plot, and using the box plot you can also see that the most of the data is lying within the minimum and maximum range, and there is one outlier that you can see beyond 300. So visually also we can check that, but that is not the confirmatory tests. But let us see with the scatter plot also. Here also we can see that this point is far beyond the most of the general data points. So that means there is an indication that this is an outlier. But when we want to calculate the outlier, we just saw that it is median plus 1.5 times the interquartile range. So for that calculation, first we will be needing what is the median. So first I will just calculate median, NP median from this data, and I get the value as 44. So we have the value, our median, as 44. Now we want interquartiles, that is Q3 minus Q1, that is third quartile minus first quartile. So for that I'll first convert this data into the pandas data frame and name it with a column 1, and then I will use the describe function of the pandas data frame. Okay, now I use it and I get all the 5-point summary with other information also. Now here you can see 50%, this is nothing but the Q2, that is the median, which is 44 we just saw, and 25% is the quartile 1. So we have 33 as our Q1 and 75% is Q3, that is third quartile, which is 54.25. So if I subtract 54.25 with 33, I get approximately 21. Now since we have the values that we need, now we will do the calculation. So the median sales is 44, the interquartile range is 21. So now the calculation says that the upper limit for deciding the outlier is median plus 1.5 times IQR. Now that is 44 plus 31.5, which is 75.5 units. Now this is our limit, beyond which if there is any value falling, that is an outlier. And in the case of September month, we see that 318 is much more than 75.5, hence 318 value is an outlier. Okay, now moving forward, let us see that there is certain key points in the real world data set, that outliers do exist in real world scenarios, and it is very important to identify outliers. Why it is important? It is because outliers affect our statistical results, hence it makes our predictions or our analysis incorrect, and outliers should be either removed or it should be dealt with other data cleaning methods. Okay, now in this lesson we learned what is the definition of an outlier, we learned the concept of outlier. Also we found that we can draw an insight using graphical representation whether there is outlier or not in a data set, and also we identified outlier using calculations. So in the next video I will also show you there are many other sophisticated ways of identifying outliers, and in this series I will also tell you some very cool ways of dealing with outliers. I hope you guys like this video. I'll see you in the next video. Please don't forget to subscribe to my channel. Till then, bye bye.